Right, continuing talking about or discussing the Doppler effect equation, let's have a look here. When the source is moving towards or away relative to the air or the listener, with the listener being stationary, we came up with that, okay? We said moving towards the listener, so let's say A here is the listener, okay? Moving towards listener. This Fs is the observed frequency is going to be greater than the frequency of the source, Fs, okay? So for that reason, we are going to use the minus in this equation so that we have a smaller fraction to multiply that, and when we have that, we actually get a greater answer there, bigger than the frequency of the source. But then if we have the source moving away relative to the air, we will have a situation where we have to make the denominator bigger so that we've got a smaller fraction. This was going to be a bigger fraction when we subtract here. So we add, we have a smaller fraction, multiplying that, we have a frequency less than the frequency of the source. That is when the source is moving away. That's when the source is moving towards. Okay, those 2 points, they are very important. Listener, this time, say it's the listener, listener moving towards or away relative to the air, towards or away to the stationary, away from the stationary source. Look at how it changed. And in fact, something is missing here, frequency of the source. We now make use of the numerator when it's the listener moving, okay? Plus or minus. If the listener is moving towards the source, we expect the frequency of the listener to be greater than the frequency of the source. And for that reason, we are going to take a plus up there so that we have got a bigger value for this fraction, so that will give us a greater observed frequency than the frequency of the source. If the listener is moving away from the source, we expect the frequency of the listener to be less than the frequency of the source. And for that reason, we will make this numerator less, and therefore we're going to go for the minus then, and therefore that would give us a frequency lesser than the frequency of the source. Okay. Next, when we put together this equation here, where both source and listener are moving relative to each other to the speed of sound in air, this is what we get, and this is what is going to be given to you as one of the formulas at the end of the year in that question paper. But you must be able to use it, and the previous discussion that I've just given you helps you to understand how do you use this formula here, because you can't use a formula with both plus and minus. Okay, you have to go for one of those. Either it's going to be a plus or it's going to be a minus. Okay, so this is when we put everything together. Okay, so we're gonna see how that is, or that equation is used in the next coming lesson. Now, summarizing this whole thing here, listener not moving, stationary, would hear a frequency bigger than that of the source when the source is moving towards the listener. Okay, understand this? The listener, stationary, will hear a frequency bigger than that of the source if the source is approaching the listener. In the same reasoning, we can say that with the listener stationary, the listener would hear a frequency smaller than that of the source when the source is moving away from the listener. Okay, so source moving away from the listener, the frequency perceived or heard by the listener becomes less. All right. Now, looking at it with this time, we're looking at it with the source stationary, trying to summarize everything. Now it is the listener moving. The listener would hear bigger frequency than that of the source. When the listener is moving towards the source, and this time it is the source that is stationary. Okay? Think of a situation like a police car with its siren on, stationary at a point. Okay, and then you are driving towards it in your car, or you are just running along the road towards where this police car is. The frequency you're going to hear is going to get bigger. It's going to be bigger than the frequency of the source, which is the siren of the car. Okay, so that is when you're moving towards the source. Now, listener hears a smaller frequency than that of the source when the listener is moving away from the source. Okay, the same example can be given. There is a police car, stationary, siren on, and maybe it's the police car, maybe the police were after some thugs and they now running away from them, and on foot they stop the car and they want to chase them on foot. They will begin to hear the siren fading away. That fading away means they are hearing the frequency which is lesser than the frequency of the source. So when the listener is moving away from the source, you hear the frequency lesser than that of the source. That is how Doppler effect works. And in the next lesson, we're going to unpack it in terms of doing calculations, putting this formula that we came up with, or these formulas that we came up with, into practice. This comes to this brings us to the end of the lesson. See you in lesson number 10.